Previously on Mr. Novik's videos. You can distribute derivatives over addition or subtraction, but you cannot distribute a derivative over multiplication or division. I promise I'll teach you how to take derivatives of product quotients soon, but I also promise that in the meantime, if you try doing derivative of f times g by doing derivative of f times derivative of g, you're going to end up in math jail, and that'll just be sad. So how do you do the derivative of a product? We know this first line is not going to be f prime times g prime. What it is, what we call the product rule, is f times g prime plus f prime times g. It's like each one gets a term being the derivative. G gets a term being the derivative, and then f gets a term having the derivative taken. So, as an example of this, if I'm doing the derivative of the product of x cubed and sine of x, I would set up the parentheses for my product rule. You don't have to do this, I just think it's easy. And f in this case is x cubed. The first time I don't take the derivative of it, but the next time around I do take the derivative of x cubed. Derivative of x cubed is 3x squared. G in this case is sine of x. The first time I will take the derivative. Derivative of sine is positive cosine. The next time around I don't take the derivative. I just write sine of x. That is the derivative of x cubed sine of x. Another example. If I want to do derivative of cosine times square root of x. The first time around, f cosine just stays there, but the next time around I do the derivative. Derivative of cosine is negative sine of x. For square root of x, the first time around I do the derivative. Derivative of x to the 1/2 is 1/2 x to the negative 1/2. I did x to the 1/2, that's the same thing as square root. The other time, though, I just write x to the 1/2. Each one gets a term having the derivative. First I did f g prime, then I did f prime g. That's the derivative of a product. Now, derivative of a quotient, derivative of division, is a little bit more complicated, and I'm not just saying that, it really is. Derivative of f divided by g is this with a little bit of that, minus some of that, and we also have some of this, but we're gonna square it. That is what we call quotient rule. The rule that tells us how to do the derivative of a quotient. Now there's a trick to remember this, and you're gonna think I'm making this up, but I swear this is real. If we call f of x the top, if we call it high, and the bottom we call low, then what we're doing is we're doing low times derivative of high, so d high, minus high times derivative of low, d low, over low squared, or maybe low if you want to call it low. That sounds like nonsense. Why did Mr. Novik convert this to baby talk? Because you'll see the way I'll do quotient rule, I'll say as I'm doing it, and many calculus people do, I swear I'm not making this up, is quotient rule is low d high minus high d low over low. After a few times saying it, it sticks in your brain. Low d high minus high d low over low, or maybe over low squared. I honestly say over low squared, but I don't know. I think calculus teachers sometimes do one, sometimes do the other. So if I'm doing this derivative, if I'm doing derivative of 3x to the 5th or sine of x, I'm doing derivative of a quotient, so I know it's going to be low d high, derivative of the top would be 15x to the 4, low d high, minus high, so the top, d low, derivative of the bottom, derivative of sine is cosine, all over low squared, all over low. So I don't do the derivative, I just do low, but I square it. And this could simplify, but that doesn't matter. Low d high minus high d low over low. We'll practice that a little bit. For this one, for the f of x, f prime of x is going to be, I'm going to do some quotient rule. I'm going to do low d high minus high d low all over low squared, low. Y equals y, that's just a product rule question. Y prime would be, remember in product rule it's a plus, whereas in quotient rule it's a minus. Just something to notice. I do first thing, and then over here I'm going to do its derivative, whereas with this one I'll do derivative of g, so derivative of cosine is negative sine of x, and then not derivative, we'll do cosine of x. This was f g prime plus f prime g. If we call f 5x squared and g cosine of x, and we ignore the fact that f and g have a totally different meaning at the top and bottom of this page, then that's my product rule. One more. G prime, I have to do low d high minus high d low. Oh my goodness, d low. That looks like a product rule, and it also looks like y, so I know exactly what d low is going to be. It's going to be from this right here, that is low, y was low, I did that on purpose. My d low is going to be negative 5x squared sine of x plus 10x cos of x, all over low squared. And just in case, we call this high, this low. I did low d high minus high d low over low low, and the way that I knew d low was because I had done it up here. It's worth mentioning some spots that people sometimes apply product or quotient rule that you don't have to. This first one is really asking the derivative of x squared times x to the 1/2. So it's really asking the derivative of x to the 2 plus 1/2. And I could just do power rule there. It's 5/2. X to the 1 smaller than 5/2 would be 3/2. You can see how someone might want to do product rule there. You could. It's not going to lead you to the wrong answer, but you're wasting a little bit of time if you do product rule as opposed to just making it x to the 5/2. This second one, you could see how someone might want to do quotient rule, but if it's constant over a function, this doesn't require quotient rule. This requires quotient rule. Derivative of 10 over x cubed, that's just asking derivative of 10 x to the negative 3. So its derivative would be negative 30 x to the negative 4. It's easy. You don't need quotient rule. If you did quotient rule, you wouldn't get it wrong, but it'll just take a little bit more time. All right, now you know product and quotient rule. We're derivative masters. Not quite, but we're getting there.